Welcome to Delgado Community College Math 120, Chapter 3.3 Video Worksheet. This video is not intended to be a substitute for reading the book, but as a supplement to the book. You should be familiar with the material either by lecture or by reading the book. Upon completion of this section, you should understand the following. Classifying a statement as a tautology, a self-contradiction, or neither. Identify logically equivalent statements. Write negations of compound statements. Write the converse, inverse, and contrapositive of a statement. At times, you should pause the video and try to answer the problem, then restart the video to compare your answer with mine. A tautology is a statement that is true for all possible scenarios. A self-contradiction is a statement that is false for all possible scenarios. For example, from the following table, we can see that the statement, you fill in the blank here, is a tautology. So if we look at a table, we know that here are our four scenarios, correct? Well, our first statement has some false values in it. But the second column, this second column is all true for all possible scenarios. That's the definition of a tautology. So the statement that we see in this table that is a tautology is P and Q implies P. Now, two statements are logically equivalent if their truth values are identical for any possible scenario. The symbol for logically equivalent is like an equal sign, but it's got three bars to it. So if we look at the following table, which two statements would you say are logically equivalent? So fill in the blank. Again, here are the scenarios. And two statements are logically equivalent if their truth values are identical. In other words, their columns will match up. And if you look at the the fifth column, and you compare it to the sixth column, notice their truth values are identical for all scenarios, and therefore the two statements P then Q and not Q then not P are equivalent. Recall, the negation of a statement is a statement whose truth values are opposite of the given statement. So if we have the negation of a statement, their truth values are opposite for any and all possible scenarios. A simple example of that would be the dog is red. Clearly, the dog not red is the negation of that statement. De Morgan's laws provide us with a formula that helps us determine the negations of the and or statements. For example, well, not for example, but for fact, if you look on the left-hand side, we have the negation of an and statement. And De Morgan's law says that we change this to an or, and notice we take the negation of the two statements. This is saying to negate an and, the statement is changed to an or statement. And then we negate both statements on each side. Our second De Morgan's law tells us how we can negate an or statement. The negation of an or is equivalent to changing it to an and negating the two statements. So if you look at both of these here, to negate an and, we make it an or. To negate an or, we make it an and. But for both of them, we negate each side of the and or the or. So this one is saying we negate an or by converting it to an and we negate both statements. So again, Look how similar they are. And goes to or goes to and, negate both statements. It may be important to memorize formulas, but more important is to be able to describe what the formula is saying. So what I'm saying here is you could go around memorizing each one of these formulas, but what are these formulas actually saying? That's important. If you can possibly put something in words, you should do it. So you answer the question here. To negate an and, you change it to an or and negate both statements. To negate an or, change it to an and negate both statements. Here's our first example of using De Morgan's law. We want to use De Morgan's law to negate the following statement. We sold peas at the market, or I was the cashier. So if we look at the list here, we know De Morgan's law says if we negate an or, it has to be converted to an and. Well, if you look at it, the only two that really here have and associated with it are these two. So we know the or isn't included. Now, we're not including this one because this actually is a negation of an and. It is not the case. And our last one, it's an or statement. So the only possibility would be the first one. So let's see if it's correct. De Morgan says convert the or to an and. We take the opposite of the first one. We sold peas. We did not sell peas. I wasn't the cashier is the opposite of the I was the cashier. So we took the or, converted it to an and we also took the negations of each side of the or. Moving on to the next one, we want to use De Morgan's law to find a statement equivalent to the following. Well, that statement here is a negation of an and statement. Well, if we're going to negate an and statement, it's going to become an or statement. So we know that the third one is not possible. The fourth one is not possible. So it's between the first and second one. Well, if you look at this, the second step in De Morgan's law is you take the opposite of the first one. Well, that's not the case for the first statement here. Opposite of bicycles have 8 wheels. Bicycles don't have 8 wheels, so we know it can't be that one. It has to be the last one here, and here's why. We went from and to an or. The opposite of bicycles have 8 wheels. Bicycles don't have 8 wheels. The opposite of helmets are worn on the hands. Helmets are not worn on the hands, so it is the second one. Now, the next formula we need to memorize here. We need to memorize De Morgan's law for negation of and or. You need to memorize them. That's all there is to it. Now, the negation of an if-then is given right here. What this formula is saying, if you want to negate an if-then, you convert it to an and. You leave the first one alone, but you take the negation, which I like to say opposite of, which is really not correct, but for a layperson's terms, it's okay. The negation of the second one, or the opposite of the second one. How do we know that? Well, if you constructed the truth table that I have here, look at this truth table. I constructed it. Notice these two columns here. Here is the negation of the if-then, and here's the statement P and not Q. Notice that their columns are identical. They are equivalent. So we know that the negation of an if-then is obtained by changing it to an and, leaving the first statement alone, but we negate the second statement. You need to memorize this. Remember, you can look and memorize a formula, but if you can speak what the formula is telling you, that is much better. So, I want you to negate the statement, if Tuesday is the name of a month, then March is not a day of the week. So let's negate that. Well, the above formula says we're going to take the if-then and convert it to an and. We're going to leave the first statement exactly the way it is. But the second statement, we're going to take its negation, its opposite. March is not a day, March is a day. So here is the negation. So, I'll repeat. To negate an if-then, change it to an and, leave the first statement alone, negate the second statement. So here's kind of a summary table of the three formulas we just visited. But notice I have them in their formula symbolic form. Let's try to again go through what they're saying. If we want to negate an and, change it to an or, negate both sides. If you want to negate an or, change it to an and, negate both sides. If you want to negate an if-then, you change it to an and, you leave the first alone, but you negate the second one. This particular section has a lot of formulas / definitions. Again, when you're given a definition, given a formula, if you can verbally state what that formula / definition actually is telling you to do, that's very important. So we're going to define the following terms for a conditional statement, P then Q. We define the contrapositive as the negation of Q, then negation of P. What this is saying, if you want the contrapositive, you're going to switch the two statements around. Notice, this went to the front, this went to the back, and you're going to negate both statements. Contrapositive. Switch, negate the two. If you would like the converse, you're just going to switch them around. Want the converse? Just switch the two statements. So I'll just take note that for the definitions here, contrapositive, converse, you're switching around, but the one with positive in it, contrapositive, notice you're negating both sides, both statements. You want the inverse? The definition of the inverse is you negate P, then you negate Q. So you're leaving everything in place. You're going to leave the P in front and the Q behind it, but you're negating each statement. So you don't switch them around, you just simply negate them in place. And we already know the negation, P and not Q, which simply says the negation of an if-then statement is converting it to an and negating the second statement. You leave the first statement alone. So once again, contrapositive, switch them around, negate the two statements. Converse, just switch them around. Inverse, leave them in place, just negate the two statements. The negation, change it to an and, negate only the second one. There you go. That's what you have to say, and that's about how fast you have to say it. So here we go. You should pause the video. Anytime I'm about to work a problem, I shouldn't have to say, you should pause the video, try to work the problem out, see if you get what I get. We have a conditional statement. If the station is playing Frank Sinatra, then the station is not playing music. We would like the converse. Before I work this problem out, I'm going to say to myself, the converse is obtained by switching the two statements around. That's all you do. So I'm going to bring the second statement forward. I'm going to bring the first statement to the back. Just switch them around. I did not do anything to them. Part B, I like the contrapositive. The contrapositive is you're going to switch the two statements around, but you're going to negate the two statements. Excuse me. So, I'm going to bring, let me use a different color here. I'm going to bring the station is not playing music forward, but notice I negated it. It is playing music. I'm going to take the first statement. The station is playing Frank Sinatra. I'm moving it to the back, but I'm negating it. Not playing Frank Sinatra. We want the inverse. If I want the inverse, I am going to leave everything in place, but I'm going to negate the two statements. So, I'll leave the station is playing Frank Sinatra in front, but notice I negated it. I'm going to leave the station is not playing music second, but again, I negated it. Not playing is playing. And now for the last one. Give us the negation. For the negation, we leave the first statement alone. We convert it to an and. We negate the second statement. So, I'm leaving the first statement alone. The station is playing Frank Sinatra. I converted it to an and then I took the second statement and I took its opposite. Not playing is playing. Negate the statement. It is not the case that Tuesday is the name of a month or March is not a day of the week. If you look at this, you should have paused the video. I don't think you did. All right. We're negating an or statement. It is not the case, right? It's an or statement. So, to negate an or, we make it an and negate each side. So, turn it to an and. On the left side, Tuesday is the name of the month. Tuesday is not the name of a month. On the right side, March is not a day of the week. March is a day of the week, and that is the negation. Well, here's a problem from Alex that's a little bit different. We're given some information, and we're given a statement. If an item is a bracelet, then the item is made from gold. We're going to figure the converse, contrapositive, and inverse. Then we're going to see if these statements are true or false based upon the information given. So the converse, we're going to switch them around. So the item is made from gold comes first. The item is a bracelet comes second. For the contrapositive, we're going to switch them around, but we also will be negating them. So we move the item is made from gold first, but we negate it. It's not. We move an item is a bracelet second, but we negate it. It's not a bracelet. For the inverse, we leave them in place, but we negate them. So, if the item is not a bracelet, then the item is not made from gold. So now let's see if they're true or false. For the first one, if an item's a bracelet, it has to be made from gold. Well, if it's a bracelet, it's made from gold, so that's true. For the converse, if the item is made from gold, then it has to be a bracelet. Well, that's not true because there are two things that are gold, and the second one is a necklace, not a bracelet, so that's false. The contrapositive. If the item is not made from gold, it can't be a bracelet. So the ones that are not gold, silver, platinum, copper, and if you look, it's not a bracelet. So that one's true. The last one. If the item is not a bracelet, then the item is not made from gold. If the item is not a bracelet, so it could be any of these, but the necklace could be gold, It could be a necklace, so it could be gold. So it is possible the item is made from gold, and that's a false statement. Well, here's another Alex type problem. Let's consider the following statement. If it is not spring, then we are going swimming. If it is not spring, then we are going swimming. We want to determine which of the following statement is equivalent, which one is a negation, and which is neither. Well, from your reading or from this video, the statement that is equivalent to an if-then, the statement that's equivalent to an if-then is the contrapositive. So, do we have the contrapositive in this list? If we are not going swimming, then it is spring. The very last statement here is the contrapositive. We know that this is equivalent. We also know for the negation, we simply convert it to an and statement. We leave the first one alone and change the second one. Well, the only hope here is this one right here. We converted it to an and. We left the first one alone. It is not spring, but we changed the second one. We were going swimming. We're not going swimming, so that is the negation. So, if we look at the other two, they are neither one. Okay, here's a table type problem. We're going to see what we're looking for in a minute here. But I want you to complete the following truth table. So, you pause the video, give it a try, but you're going to need some additional columns. So, here we go. Again, you should pause the video though, right? I'm watching you. So, we're going to add some columns here. Now, again, what I like to do is work left to right as much as possible. So, the first thing I come across is this. Let me put my marker on. The negation. I can perform the negation because I know the P column. So, I'm going to put the negation of P, opposite of true, opposite of true, opposite of false, opposite of false. Moving on, I would like to complete the AND operation. Since I now have the negation of P and I have Q, I can construct that operation, not P and Q. So looking at the Q column and looking at the not P column, we're working with an AND. They both have to be true. They're not both true. They're not both true. They are both true. They're not both true. Moving on, we want to do the OR, but we can't perform the OR operation because we don't know the right-hand side. So we're going to skip it. We try to do the OR here. But again, we're going to have to skip it because we need the negation of Q. So we're going to do the negation of Q. The opposite of true, the opposite of false, the opposite of true, the opposite of false. Now that we have the negation of Q, we can go back and do P or not Q. So working with the column P and working with the negation of Q column, this is an OR, we need at least one true, right? We have at least one true. We have at least one true. We don't, and we do. So that's that column. We are ready for the entire argument now. We have the left-hand side right here. We have the right-hand side right here. We're joining them together with an OR, so we need at least one true. We have 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 at least one true. Well, guess what we have here? Can you guess? Well, let's see. We're asking you now, is our statement above a tautology? A tautology is a statement that is always true for any scenario. Our statement here is column is always true. So yes, the statement is a tautology. Okay, reading the problem, let's work it out. We have statements defined by P and Q. I want you to convert our first statement to its symbolic form. So again, you should be pausing the video. These are pretty simplistic, so I'm going to get moving here. So you should have for the first one, Q then P. You should have for the second one, not P then not Q. Okay, you see that? Well, here's our question. Are these statements equivalent or not? If you want to determine if two statements are equivalent or not, well, one thing you can do is to construct a table for the two statements. The first one and the second one. Now, you may need to add some rows here. I'm going to get this over with. They're all pretty short. So I'm going to just work them straight out. Q then P. Just be careful. This is backwards. So we're not looking for a T then an F because it's backwards. We're actually looking for an F then a T to be false. So the first one's okay. The second one's actually okay. The third one is our troublemaker. And the last one's okay. Because again, we were looking for Q then P. So we're actually going in the opposite direction. If then is one directional. It's not commutative. Now if you look at the second column and you look at the negation of P then the negation of Q. False then a false. I'm okay. False then a true. I'm okay. True then a false. We're not okay. True then a true. We are okay. Now if you notice, the two columns are identical. So they are equivalent. Now, if you realized, notice that this statement here is an if-then. How do you find the contrapositive? You switch them around and you negate the two. That's the contrapositive. So from that simple fact, I know the contrapositive is equivalent to the if-then. So in a way, I could have gotten away with not doing the table because I knew that the second one was the contrapositive. And we know that contrapositive is equivalent to the if-then. Well, that's all, folks. I hope this one helped you. And I hope there are more down the road here. Thank you.